Welcome to Brain Vision.
In this problem, we want to figure out the tensions of both the ropes. We know that this thing is swinging in a circle, so there's going to be a radial acceleration involved. So I'll go ahead and write the form down here. It's v squared over r. Now we're given a velocity, but we're given it in revolutions per minute. So it's 28.0 revolutions per 1 minute. And so it'd be nice to convert this revolutions per minute into meters per second using the known radius of the revolution. And so first I'm going to convert minutes to seconds. 1 minute is 60 seconds. And then I'm also going to convert 1 revolution into 2 pi r meters, since 2 pi r is the circumference of a circle. Now r is known in this problem to be 7.5 meters. And so doing this out, doing this 28 divided by 60 multiplied by the circumference here, I get that v is 22 meters per second. Now I'm going to go ahead and draw a force diagram for the situation. I have gravity pulling us down. So this is equal to m total times g, which is also equal to w total, the total weight. I have T1 pulling us to the right. I have the horizontal component of T2, which is equal to T2 times sine of 40. And then I have the vertical component of T2, which is equal to T2 times cosine of 40. And those are my forces. So I know this thing's not accelerating in the y direction. So I can say that the sum of the forces in the y direction is equal to 0. Adding in my forces here, I get that T2 times cosine of 40 is equal to the total mass times g, which is also known as the total weight. Solving this for T2 gives me 1,410 newtons. And so that's one part of our answer. Now I'm going to do the sum of the forces in the x direction. In this case, it's not equal to 0 because we are accelerating. And so we have to add in m times a, where this is the radial acceleration here, like that. Now adding in the sum of the forces, I get T1 plus T2 sine 40 is equal to total weight over g. Here I'm just replacing the total mass with the total weight over g times v squared over r. This implies that T1 is equal to 1080, because that's the total weight, over 9.8. And then now we need the velocity, which is 22, and it's squared, over the radius, which is 7.5. And then we have to subtract T2 times sine 40, which is 1,410 times sine 40. Doing this in the calculator yields 6,206 newtons. So the tension in the first rope is way bigger than the tension in the second rope. And that's the